What if the strongest sounding argument you ever made was full of holes, and you had no idea? That is not a hypothetical. It happened to me, and it took 5 AI models to prove it. Today we are running a head-to-head test to find out which AI is actually best at spotting logical fallacies in your own arguments. Logical fallacies are errors in reasoning that make an argument look valid when it is not. You have probably heard of the most famous ones: straw man, ad hominem, false dichotomy. But the tricky ones are subtle. They hide inside confident, well-structured sentences, which is exactly why most people never catch them in their own work. The experiment started with a question I have been sitting on for a while. AI tools are being sold as thinking partners, reasoning assistants, logic checkers. But do they actually hold up when the argument in front of them is genuinely flawed? I needed real data, not marketing copy. I chose 5 models that represent the current landscape of large language models available to everyday users. I am not going to list brand names here because the point is not which company wins, it is what the results tell us about how these systems process logic. What I will say is that the 5 models ranged from the most widely used consumer tools to a couple of newer reasoning-focused systems. Before I could test anything, I had to build the arguments. This was harder than I expected. I wrote 10 short arguments, each roughly a paragraph long, and each one contained exactly one logical fallacy. The fallacies ranged from obvious to subtle. Straw man and appeal to authority on the easy end. Base rate neglect, the conjunction fallacy, and the nirvana fallacy on the harder end. Here is an example of one of the easier ones I wrote. I argued that because a famous scientist supported a particular diet, that diet must be healthy. That is a textbook appeal to authority. I expected every model to catch this one without much trouble, and I was mostly right. But the quality of the explanations varied a lot, and that difference turned out to matter. Now here is one of the harder ones. I wrote an argument about vaccine risk that used accurate statistics but framed them in a way that ignored base rates. The absolute numbers sounded alarming, but compared to the actual population size, the risk was tiny. Catching that requires more than keyword matching. It requires the model to do real proportional reasoning. I used the same prompt for every model. I said, here is an argument I wrote. Identify any logical fallacies present, name each fallacy, explain why it applies to this specific argument, and tell me how I could fix it. Simple, consistent, and fair to every model. No additional context, no hints. The results on the easy fallacies were about what you would expect. 4 out of 5 models correctly identified the appeal to authority and gave reasonable explanations. The 5th model identified it but mislabeled it as a different fallacy, which is still a partial credit situation. None of them missed it entirely. Good start. The straw man arguments were more interesting. I wrote a version where the distortion was subtle, not a complete misrepresentation but a slight exaggeration of the original claim. 3 models caught it. 2 models said the argument was logically sound. That gap is significant if you are relying on AI to review your work before you publish or present it. The base rate argument was where things got really revealing. Only 1 model correctly identified the base rate neglect and explained it in a way that was both accurate and useful. 2 models said the argument was fine. 1 model flagged a different fallacy that was not actually present. And 1 model gave a vague answer about the statistics being misleading without naming the specific error. That false positive is worth stopping on. 1 model told me I had committed a false equivalence fallacy in an argument where no false equivalence existed. When I pushed back with a follow-up prompt asking the model to justify the claim, it doubled down with a confident but incorrect explanation. This is a real problem. If you are using AI as a logic checker, a confident wrong answer can be worse than no answer at all. Across all 10 arguments, I scored each model on 3 things. First, accuracy. Did it correctly identify the fallacy that was there? Second, depth. Did it explain why the fallacy applied to this specific argument, or just define the fallacy in general terms? Third, usefulness. did it tell me how to actually fix the argument? The scores were not close at the top. The top-performing model got 9 out of 10 correct identifications, gave specific explanations in 8 of those cases, and offered actionable revision suggestions in 7. The lowest-performing model got 6 out of 10 correct, and most of its explanations were generic definitions that could have come from a basic textbook. Knowing the name of a fallacy is not the same as understanding why it appears in a specific argument. There was one pattern that showed up across almost every model. They all performed better on fallacies that have strong linguistic markers. Ad hominem attacks usually involve words directed at a person. Straw man arguments often use phrases like saying you believe something extreme. The models that struggled were the ones that had to reason about what was missing from an argument, like a missing base rate, rather than what was wrong with what was there. This tells us something important about how these models work. They are pattern matchers at a very deep level. When the fallacy has a clear textual footprint, they find it. When the fallacy lives in a gap between the data presented and the data omitted, they often miss it. That is a limitation worth knowing before you hand your draft over to an AI and assume the logic is now sound. So how should you actually use these tools? The best approach I found is layered. Use the AI as a first pass to catch obvious fallacies and surface-level errors. Then ask the model specifically about any claims that involve numbers, comparisons, or cause and effect relationships. Those are the areas where the reasoning gets thin. Do not treat a clean AI review as a final stamp of approval. There is also a prompt engineering angle here. When I changed my prompt from a general fallacy check to a targeted question, asking specifically whether the argument commits any fallacy related to statistical reasoning, the accuracy of 2 of the weaker models improved noticeably. Narrowing the scope of the question helps the model focus. That is a practical trick you can use today. The bigger takeaway from this experiment is not which model number 1 was. It is that all 5 models have real gaps, and those gaps follow predictable patterns. If you know the pattern, you can compensate for it. You can prompt around the weaknesses, combine outputs from 2 models, or use the AI response as a starting point for your own deeper review rather than an ending point. I also came out of this experiment thinking differently about my own arguments. Even when the AI was wrong, the process of seeing my writing through the lens of fallacy detection made me more careful. I caught 2 genuine problems that I had not designed into the argument, errors that crept in while I was writing. That is the real value here, using AI to make yourself a sharper thinker, not a lazier one. If this kind of practical AI comparison is useful to you, hit the like button because it tells me to make more of these. Subscribe so you do not miss the next video, which is going to be a similar test but focused on a different skill entirely. I am going to ask the same 5 models to fact-check a set of claims, some true, some false, some somewhere in between. The results are going to challenge what you think these tools are actually good at.